Hello guys, I hope I find you well. In this video, we are looking at angles of elevation and depression, okay? So, we are going to start by discussing the angle of elevation, which is represented by the small letter E here, okay? So, let's dive into it. Okay, so there's some information here which will help us to appreciate or understand angles of elevation. So I'll read the girl G, this girl here, is looking at the top of the tree T, which is shown by the letter T. To do this, she has to raise her line of sight through an angle E degrees from the horizontal, okay? So this is the horizontal. So this girl must raise her line of sight from the horizontal up to this, and in the process making an angle of elevation of E degrees so that she could see the top of the tree shown by this T here. Okay, so the angle of, let's proceed, the angle of elevation of T from G is the angle which GT, this GT is the angle which GT makes with the horizontal, this horizontal. The angle E degrees, this one, is called the angle of elevation of T from G, of T from G. So mean to say, we measure angles of elevation starting from the horizontal up to the line of sight which is going to the object which you are viewing, okay? Okay, now let me explain the angle of depression. Okay, let me read here. The man at B, this one, is looking down at his friend at C. To do this, he has to lower his line of sight from the horizontal through an angle D degrees. So this is our horizontal, and he has to lower his line of sight so that it comes here, and in the process making an angle of D degrees between the horizontal and the line of sight. Okay, so the angle of depression of C from B is the angle which BC, this BC, makes with the horizontal. Okay, the angle D degrees, this one, is called the angle of depression of C from B. Okay, so mean to say, angles of depression are measured from the horizontal, looking down, making an angle between the horizontal and the line of sight. So the angle between the horizontal and the line of sight going down is called the angle of depression, shown by the letter D here. Okay, so there is a useful connection between angles of elevation and angles of depression. Okay, so there is a connection between angles of elevation and depression. So I've used, let us go to this diagram to illustrate the connection or the relationship. Okay, so we have got a cat here, C, and a dog, D. These are horizontal. Okay, so the angle of depression, this D, of the dog, okay, the angle, let me start with the angle of elevation, okay? So the angle of elevation of the cat C from the dog D is equal in size to the angle of depression of the dog D from the cat C. They are alternate angles, okay? So here the connection is that this angle of depression of D from C is equal to this angle of elevation of C from D. Okay, so they are alternate angles. Okay, so let me give you a question to enhance our understanding, okay, so that you can appreciate better the angles of elevation and depression. So here we've got a question which says, at a distance of 70 meters from the base of a tower, I measure the angle of elevation of the top, that is the top of the tower, as 35 degrees. If my eye is 1,50 meters above ground level, calculate the height of the tower. In other words, the line of sight here is 1,5 meters above 1,50 meters above the ground. So you want to calculate the height of the tower. So using this diagram, here we can see that we want to find this height of the tower is shown by the letter H. So this one is our tower, the top labeled as T. So from the information given in the question, you know that from the base of the tower to the observer here, there are 70 meters between them. From the base of the tower to this person, there are 70 meters between them. But the eye level or the line of sight of this person is 1,5 meters from the ground. So measuring from his line of sight or from his eye level, we know that the angle of elevation of the top of the tower T from the eye level E is 35 degrees. Okay, so we want to find the height of the tower. So for us to find the height of the tower, we must find this height TD using trigonometry. And then when you find this height TD, we are going to add this 1,5 from D to the ground, 1,5 meters, 1,50 meters. Okay, so we want to first of all find the height TD using trigonometry. As you can see, this one, triangle TDE, is a right-angled triangle with an acute angle of 35 degrees. Okay, so let's proceed. Here we are. Okay, let me, so that you can see clearly. Don't want it to be obstructed. Right, okay, so here we are. From the previous diagram, we have come up with this one, okay? As you can see that TD, and from D to the ground there are 1,50 meters. Up to the from the ground to the eye level, there are 1,50 meters. So we want to first of all find TD using the right angle triangle TDE. So from SOHCAHTOA, from the acronym SOHCAHTOA, we can see that this TD is the opposite side, but it is opposite this acute angle, and the DE is the adjacent. So we are going to use the tangent ratio. So tan 35 degrees equals opposite over adjacent with dt over de. Tan 35 degrees equals dt over 70. So finally dt equals 70 multiplied by tan 35, which is 49 meters, correct to two significant figures. So finally the height of the tower, we are supposed to add TD plus this height of 1,50 meters. So height of the tower equals 49 meters plus 1,50 meters, which is 50,5 meters. Okay, thank you for watching. See you in the next videos.